soon as possible, so that way you don't really have to worry about it. Any question before I start the lecture? All right, so what I'm going to go ahead and do, I'm gonna go ahead and switch over to my lecture notes so that way you can see the lecture notes. All right. So let's get started. So if you kind of remember at the very end of Monday, we started and we did part A. So for part A, we wanted to describe the sampling distribution of p hat. So when we did the description of the sampling distribution of p hat, we got mu of p hat, we got sigma of p hat, and we were also able to figure out that the data set was approximately normal because of the central limit theorem, because when we did n times p times 1 minus p, it was found that pretty much when you multiply that out, you got 37.5, which was greater than or equal to 10. So since 37.5 was greater than 10, pretty much we could say it's approximately normal because of the central limit theorem. So now what we're gonna go ahead and do, we're gonna go ahead and find the probability of this event occurring. So what we wanna go ahead and do for part B, we're gonna find the probability of p hat being greater than 0.78. So that you're saying if we have a population mean that's 0.75, what's the probability if we gather a sample that sample will have a probability of 78% or higher. So we want to find what is the likelihood of that occurring. So let me get my pencil and let's start doing this. So the same thing, you first want to start off with a drawing. So you want to draw this out. So we know that this is approximately normal, so that's why we do the normal distribution, which is a symmetric distribution. So if you remember, the middle is your average. In this case, we're going to use the average of p hat. So the average of p hat is 0.75. So that's what we're going to put in the middle. Now what we're going to do, we're going to put what are we trying to find the probability for, or what are we trying to find the likelihood of occurring. So we're trying to find how likely in a sample we could get 78%, because that's what this is saying. So we go 0.78 should be somewhere over here. And if you look at the symbol is greater than. So greater than means we want it to be bigger than 0.78. So if we want it to be bigger than 0.78, that means we want the probability to the right. All right. So far, everybody go for this drawing. All right. So if you kind of remember from Monday, in order to find the probability, we use normal CDF. So we're still going to use normal CDF. So we're still going to use normal CDF. So if you remember for normal CDF, it's going to ask you for mu. It's going to ask you for sigma. It's going to ask you for the lower bound. And it's going to ask for the upper bound. The only thing different, instead of putting mu, we're gonna put mu of p hat. And instead of sigma, we're gonna put sigma of p hat. So if you look at this one, we already found mu of p hat. We found mu of p hat to be equal to 0.75. So you put 0.75 here. If you look at what we found sigma of p hat to equal to, sigma of p hat is equal to 0.0306. So we put 0.0306. Lastly, if you look at the lower bound is the lowest value that gets shaded. So the lowest value that we have that gets shaded is 0.78. So that's our lower bound. So you put 0.78. If you look at the highest value that get possibly shaded, since this keep on going to the right hand side, we're gonna say is going to infinity. But just remember your calculator doesn't have an option for infinity, so we're gonna put 10 to the 10 power. Any questions so far on what I enter for normal CDF? Okay, so if there's no question, we're gonna move on, and we're gonna move on to the TI-83. So let me share the TI-83 with you. So first we're gonna turn it on. I'm gonna clear this. I'm gonna hit second, and we're gonna go to bars. If you look at it, we're gonna still use the normal CDF as we did last week, or sorry, last Monday. So for the lower, we said it was 0.78. So we put 0.78. For the upper is positive infinity. So just leave it as positive infinity. For my mu we said was 0.75. And for standard deviation was sigma of p hat. So that was 0.0306. So we go ahead and do a paste. We hit enter. And you got that probability. All right. Any questions so far on how I enter it into the calculator to get 0.1634? What answer did you get? Here, let me double check what I answered. Oh, let's see, yeah. Yeah. And you put exactly what I have here on your calculator and you use normal CDF? Okay, yeah. Yeah, you switch that around, that should fix it. All right, any other question in regard to pretty much how to enter this into the calculator? Okay, so I'm gonna go ahead and switch over to my notes, for that way you can see how I wrote down the answer. All right, so if you see the one highlighted in hot pink, that's your answer. So we're gonna say the probability that a sample proportion will get a probability of 0.78 or higher. the likelihood of that occurring is 16.3%. So you're telling us if we have a sample of, what was the sample? The sample of 200. If we have a sample of 200, the probability that of those 200, we get 0.78 or higher, the likelihood of that occurring is 16.34%. And that's it for that problem. Any question in regard to part B? Okay, so let's move on. Let's do part C. So part C, same thing. We're gonna do the drawing. We're gonna see how should we enter that into normal CDF, and then we're gonna go on from there. So let's do the drawing. So the middle should be 0.75. So in this case scenario, now we want to find, hey, what is the likelihood that if we have a sample of 200 object or people, what is the likelihood that if the mean is 75%, that we get a probability of 63 or smaller than 63? So let's go ahead and put 63. So 0.63 is smaller than 0.75. So you put it on the left-hand side of 0.65. Or sorry, 0.75. So if you look at the symbol that we have here, it says less than. So since it's saying less than, that means we want to shade the left-hand side. So you shade the left-hand side. So far, everybody good with that shading? All right. So now that you got the shading, this should help you assist you to do the lower bound and the upper bound when we're doing the normal CDF. So we're gonna go ahead and do normal CDF. So we're gonna say normal CDF. And we could say mu. We're gonna put sigma. We're gonna put the lower. And we're also gonna put the upper. So if you look at mu and sigma should be the same. That's not changing. It's still gonna be mu is 0.75 and sigma is 0.0306. So since it's the same problem, the mu and the sigma is gonna stay the same. The only thing that's changing is my lower bound, my upper bound. So for my lower bound will be the lowest value that we shaded. So if you look at that, you keep going and going and going. So we're gonna say keep going to negative infinity because it's going to the left-hand side. So we'll say negative infinity. So that's negative 10 to the 10 power. So then if you look for the upper bound is right over here, is the highest value that we possibly shaded, which is the 0.63. So since that's the highest value that we shaded, we put 0.63 as your upper bound. Any questions so far on what we have for mu, sigma, lower, or upper? So let me go ahead and write this before I go over to the TI-83. All right, so right now we're gonna go ahead, we're gonna switch over to the TI-83. So let me go ahead and turn this on. So I'm gonna go second. You're gonna hit the bars button and we're gonna select the second one, which is normal CDF. All right. So if you look at my lower bound, we want to change that to 0.75. Well, sorry, lower bound is negative 10 to the 10 power. So you put negative 10 to the 10 power. For my upper bound, if you look at my upper bound we said was 0.63. So you put 0.63. For mu we said was 0.75. And lastly, we have sigma, which was 0.0306. So I'm going to go ahead and go to paste this out. All right. And if you look at it, it gave us 4.4. And like one thing that you should kind of already be cautious about, like we can never have a probability bigger than 1. So when you see 4.4, you know something is different. And that's where you have to look at the very back end, and you should see that it says e to the negative 5. So the 4.4, if you put 4.4, that will be the incorrect answer, because if you put 4.4, you're saying that has a 440% chance of occurring. So that just doesn't make sense, because the highest value it can possibly be is 4. You have to take note of the e to the negative 5, because the e to the negative 5 is telling you that the 4.4 is in scientific notation. So you have to go from scientific notation and you change it to standard notation. So I'm going to change it to standard notation on the notes page. All right. But any questions so far? I got 4.4 e to the negative 5.
So it's going to be like 0.00004.
Yes.
That makes a lot more sense than 440%.
Exactly. Okay, so I'm gonna switch over to the notes for that way you can see how to convert a scientific notation into a standard notation. So here goes the scientific notation. So it says 4.4 e to the negative 5. So pretty much when you have the e represent 10, and then the negative 5 means pretty much 10 to the negative 5 power. You don't really need to know all of that. The only thing you have to know that this negative 5, since it's negative, it's telling you grab the decimal point and you move it 5 spaces to the left. So I'm going to grab this decimal and we're going to move it 5 spaces to the left. So you go 1. Oops, did not want to do a circle. There you go 1. You go 2. You go 3. You go 4. And you go 5. And this is where you move the decimal to. So anywhere you see an empty shell or an empty area, that just means you put a 0 for those empty spaces. So that means we put 0, 0, 0, 0. So technically our final answer should be 0.000044. Or you could put 0.0004. All right, and that's it for that one. So if you look at the likelihood of this occurring, it's kind of telling you it's not very likely to occur, because it's not even a 1% chance of occurring. It's less than 1% to occur. All right, but that's it for the last prompt. Any question in regard to the last prompt? All right, so let's go on down. So let's do word problem. All right, so let's do this one. So it says, according to the Bureau of Labor Statistics, 5% of the population survey was unemployed at the end of 2019. So the 5%, so if you look at it, it says 5% of the population survey was unemployed at the end of 2019. So that's telling me that the population proportion is equal to 0.05. So pretty much that one statement that they give us, that's the only thing pretty much important that they give us. They're telling us the population proportion of unemployment at the end of 2019 was 5%. So we're gonna say P is equal to 0.05. Everybody go on P is equal to 0.05. Okay, so let's move on to A. So if you look at A, it says describe the sampling distribution of P hat for a random sample of 250 people. So they tell me what to do, and they're telling me how many people we have. So they're telling me we want to describe the sampling distribution of p hat. So once they tell me that, you should already know that we're going to be finding mu of p hat. We're going to be finding sigma of p hat. And we're also going to see if the distribution is normal, not normal, or if it's approximately normal. All right. Everybody good so far on what the describe the sampling distribution? What is that asking for? All right. So also the next thing that they give you, they tell you we have a random sample of 250 people. So if they're telling me we have a random sample of 250 people, that is just giving me n. So n is equal to 250 people. All right. So now we're able to go ahead and find mu of p hat, sigma of p hat, and we're also able to figure out the distribution. So for mu of p hat should be pretty straightforward. Mu of p hat will just be equal to p. So p is equal to 0.05. So we're going to put mu of p hat is equal to 0.05.
Quick question. I'm just forgetting what the hat means exactly in comparison to P.
All right, so pretty much we have P. P corresponds to population. Oops, did not want that. No, that's weird. All right, so P corresponds to a population proportion. When we have P hat, that corresponds to a sample proportion.
Got it.
So this is kind of going back to the definition. If you remember all the way, like in chapter 1, when we learned about parameter and statistic, P is your parameter because that's the thing that's coming from the population. P hat is your statistic because that's coming from a sample. All right. So yeah, you're welcome, Alan. So up next, we're gonna go ahead and do sigma of p hat. So sigma of p hat, you have to just remember the formula, or you just make sure that you have the formula jotted down somewhere. So sigma of p hat will be equal to p times 1 minus p divided by n. So what we're gonna go ahead and do, we're gonna do square root of p, which is 0.05. We're gonna do 1 minus 0.05, and you're gonna divide this by n, which we found to be 250. Everybody good on how I substituted into that formula? All right. So what I'm going to go ahead and do, I'm going to go ahead and switch over from the notes to the TI-83. For that, we could kind of see how I enter into TI-83. And you try to follow along for that way you can see if you get the same answer that I do in the TI-83. So I'm going to clear this. So the first thing you want to do, you want to get the radical. So if you look at the radical, in order to get the radical, you have to hit the second button. And you want to go where it says x squared. And that will give you that radical. So then what you want to do, you want to put p. So p is 0.05. Then what you could do parentheses, which is above the number 8. And you have to do 1 minus 0.05. Close parenthesis. Then you use the division sign. And then you put 250. And the one thing you should be looking at, if you look at mine, you see how the radical is over everything? That's telling you that everything is underneath the radical. Because say like if you do the radical, if you do 0.05, and then you do 1 minus 0.05. If you look at the 1 minus 0.05, if you look at it, you see how the line is not over that portion? That's telling me that the 1 minus 0.05 is not under the radical. So you kind of be careful when you're doing the radical. All right, but if you look at the answer that we get 0.0137, or we could round the 7 up to an 8. So we're going to say sigma of p hat is equal to 0.0138. So that's your sigma p hat. Everybody good on sigma p hat? All right, so I'm going to go transition over to my notes again. Thanks for the thumbs up. All right. So we already found mu p hat, we already found sigma p hat. Now we want to see what type of distribution are we dealing with. Are we dealing with a distribution that's normal, non-normal, or is it approximately normal? So first thing I want to do, I want to check the problem. And I want to see, do they ever tell us that the population survey for unemployment, is that normal? And if you look at the problem, nowhere in the problem do they tell us that it comes from a normal distribution. So we already know we can't state it's a normal distribution. So what we have to do, we have to see if we could say it's not normal or if it's approximately normal. So to say it's approximately normal, we're going to apply the central limit theorem. So we're going to use the CLT. And for this one, you have to be cautious because remember, there are two central limit theorem, one that we learned in 8.1, one that we learned in 8.2. 8.1, the central limit theorem that we learned for 8.1 is if you're dealing with the population mean. If you're dealing with the population mean, you have to check to see if n is greater than or equal to 30. But if you're dealing with the population proportion, you have to see if n times p times 1 minus p, if that's greater than or equal to 10. So you do have to kind of look at your data set and go like, am I using the mean or am I using the sample proportion? If you're using the mean, you do n is greater than or equal to 30. But if you're using proportional data set, you have to check to see if n times p times 1 minus p will give you greater than or equal to 10. So let me write that down. So we're going to say n times p times 1 minus p. That has to be greater than or equal to 10. So I'm going to go ahead and substitute everything in. Hopefully I have space for that. So you do 250 times 0.05 times 1 minus 0.05. So this is what I'm going to multiply on my TI-83. I'm going to do 250 times 0.05 times 1 minus 0.05. So let me switch over to the TI-83. All right, so we're going to say 250 times 0.05 multiply by 1 minus 0.05. Close parenthesis, press enter. All right, so we get 11.875, which is indeed greater than 10. All right, everybody good on 11.875? All right, so let me transition over into the iPad or to my notes. All right. So if you look, I wrote that 11.875 right here, and I wrote that it's greater than 10. So since it's greater than 10, this is not normal. This is approximately normal. So since it's approximately normal, we could continue on and still find the probability of this event occurring. All right, but that's it for A. So that's all you have to do for A. Any question in regard to letter A? All right, so let's go on to B. So if you look at B, it says in a random sample of 250 people, what is the probability that 17 or fewer people are unemployed? So we kind of think about it, you have 250 people, and they want to know what is the likelihood that 17 out of the 250 people or fewer than 17 are unemployed. So for our p hat, kind of going back to the beginning of chapter 8.2, if you remember p hat, this pretty much the definition for p hat or the formula for p hat is x divided by n. X, if you remember, is the characteristic that we're looking for. So X is how many people are unemployed. And you divide that by how many people did they sample. So if you look at it, we're going to do how many people are unemployed divided by how many people did they sample. So if you look at the problem, they tell us 17 or fewer. So that means P of hat will equal to 17 divided by however many people they randomly selected, which is a 250. All right. Everybody good? 17 divided by 250.
Yep.
Perfect. All right, so I'm gonna do 17 divided by 250. If you actually do that in your calculator, you get 0.068. So I'm gonna go ahead and draw this out. We're gonna do the normal CDF, and we're done with this problem. So let's draw this out. So 0.05 goes in the middle. 0.068 go to the right of it because 0.068 is bigger than 0.05. And if you remember, they wanted to be fewer people. Fewer people mean less than. So you say the left-hand side.
So this is like our other problems, except we had to figure out kind of what they wanted, opposed to like P is, then parentheses P hat less than 0.68. We just had to figure out that percentage that it was going to be, right?
Yeah, exactly. So like in the other problem, I gave you those percentages, but in this problem, like I tell you how many people do we want out of the total amount of people that they sample. But you approach it the same way. Like the only thing you have to do a little extra steps that you first have to find what is that p hat equal to, but it shouldn't really be that much of a difficult process.
Great. Thanks.
Yeah, you're welcome. All right, so this is our drawing. So just remember for the drawing, it's not absolutely must that you draw this distribution, but it should be pretty helpful for you for tests and for quizzes. So if you feel like it's helpful for you, draw it. If you feel like you don't need to draw it, don't draw it. Like it's up to you. All right, so up and we're gonna go ahead and do is we're gonna go ahead and figure out what are we gonna put for the normal CDF. All right, so I'm gonna follow the order of normal CDF. So it always wants the lower bound first. It wants the upper bound. Then it wants mu, and then it wants sigma. So if you look at the lower bound is all the way here in the left-hand side. So if you look at the left-hand side, we're gonna say since it's going to the left-hand side, we're gonna say it's going to negative infinity. So that's negative 10 to the 10 power. If you look at the upper bound is the highest possible value, which is this one. So that'll be 0.068. Everybody good with the lower bound, negative infinity. The upper bound is 0.068. All right. So up next, we're gonna go ahead and do, we're gonna put mu and sigma. So for mu and sigma, we actually already did that for part A. So if you look at part A, we put mu is 0.05. So you put 0.05. If you look at sigma, we got 0.0138. 0.0138. So this is exactly what we're gonna put in our TI-83. And once we input this in the TI-83, it should give us the answer of the probability that P hat is less than, if you want, you could put 17/250. Or if you want, you could put what that actually resulted in, 0.068. So both of them are equivalent because 17 divided by 250 is 0.068. So, all right. So up next, I'm gonna go ahead and do your transition over to the TI-83 and we'll TI-84 and enter it, and we should get our final answer. All right. So let me turn it on. So first, go to second, go to bars, go to normal CDF. If you go to normal CDF, if you look at it, well, it already have the lower bound, -10 to the 10 power. The upper bound, if you look at the upper bound, is 0.068. If you look at my mu, is 0.05. And if you look at sigma, is 0.0138. So we go here and paste, we enter it, and you get that for your final answer. So you get 0.9039. All right. And that's it for that part B. Any question in regard to part B? All right. So for this one, if you actually want to draw the distribution, when you go to distribution, if you look right here, it has draw. And it has shade normal. So if you look at it, we can put the lower bound. So the lower bound we'll put here. We'll put -10 to the 10 power. If you look at the upper bound 0.068, 0.068. For our mu is 0.05. Our sigma is 0.0138. And we go ahead and draw. Okay, so let me turn off my plot. So if you look right now, I have this plot on. So I do want to turn that off. So I'm going to turn this off. So let's try that again. So we go second, bars, draw. We'll do shade on normal. All right, have to put it all over again. So we'll say -10 to the 10 power. We'll put upper, which is 0.068. We'll put mu, which is 0.05. We'll put sigma, which is 0.0138. And we'll go ahead and draw. All right, so let me go to zoom 9.
I got an error on a TI-83. I got invalid DIM.
I guess it's not working. Or, well, you scratched that. All right, but you know how to do the normal CDF. That's all that matters.
All right, great.
So let's go back to part C. That's weird, it didn't work. I'll mess around with it. All right, so let's do the final one for this one, and then I think I have one more for practice. So for this one, it says, in a random sample of 200 people, what are the probability that at least 7% are unemployed? So once again, is 0.05 because we're still dealing with people who are unemployed. So if you look at it, this time I gave you the percentage. So the percentage is 7%. So 7% is bigger than 5%. So that should be 0.07 over here. So up next is the word at least. So you kind of just have to just remember the definition of at least. At least means that's the minimum, but it could be higher than that value. So it's telling me the minimum is 7%, but it could be bigger than 7%. So we say all of this. All right. Everybody good so far with the drawing of the normal distribution? All right, perfect. So let's go ahead and just put out what should we enter into our normal CDF. So we're gonna put lower, we're gonna put upper, we're gonna put mu, and we're gonna put sigma. So if you look at the lower is the lowest possible value that we have. And that value is 0.07. So that's the cutoff that we have for the lower bound. So then we have to look at the upper bound. So we have to look at what are the highest values that we have shaded. So the highest possible value that we have shaded, well, if you look at it, we don't actually have a cutoff. You keep going and going and going. So we're gonna just assume we keep going to positive infinity. So we're gonna say 10 to the 10 power. Then what we're gonna do, we're gonna give it the mu value. A mu value is the same one that we use for part B because that's what we got for part A. Mu should be 0.05, and then sigma should be 0.0138. Everybody good so far on the input of what we're gonna put into normal CDF? So lastly, I'm going to show you how to write it. So we're going to say probability that p hat is greater than or equal to 7%. Or actually, let's write that as 0.07. But you also remember, it doesn't really matter if you put the equal sign, because you could just still write it as probability of p hat is greater than 0.07. And both of them are exactly the same thing. Okay, just remember, for a continuous data set, it doesn't matter if we include a value or don't include it, you still should get the same value. All right, so up next, I'm gonna go ahead and move over to the TI-84. For that way you can see how I input it. So we're gonna go second, bars. We're gonna do normal CDF. So for the normal CDF, for the lower bound, we'll put 0.07. For my upper bound, we'll put 10 to the 10 power. Oop, not division. 10 power. And if you look at it, since we're still continuing with the same problem, it already has the mu and it already has the sigma for me. So I'm gonna skip that part. We're gonna go here, paste. We'll go to enter. And we'll go and put that the final answer is 0.0736. 0.0736. So I'm going to transition back to the notes. For that way you can see how I enter the answer. So if you look right on the bottom, that's your answer. So the probability that we get more than 7% of the 250 people to be unemployed, well, there's only a 7.36% chance of that occurring. So it's kind of telling you that doesn't happen that often. So if we have 250 people, the chances that we have more than 7% of them being unemployed is not very likely. All right, but that's it for that last problem. Any question for that last problem? All right. So up next, what I'm going to do, I'm going to give you this problem, and I want you to practice on this problem. Let me see if I have the parsing. Yeah, no parsing. All right, so I want you to practice on this problem. So practice on this problem on how to get the sampling distribution. Also figure out how to get the probability, so that way you can get practice on how to do this, so that way you can kind of make sure that you understand what we've been doing for the last 50 minutes. So try doing this problem. If you get stuck, you could message me, you could private message me, or just shout out what your question is. For that way I can help you out. All right, but just practice on this one right now.